Concrete column, video 1, section and loads. With the program concrete column, columns and walls can be designed in the ultimate limit state or controlled in both the ultimate and serviceability limit states. At start of the program, the correct national annex to the Eurocode should be defined, and we have in this case chosen the Swedish annex. In a number of instructional videos, we will go through how to specify the input and interpret the results. Under the option Help on the main menu, the program manual is available. Select Content and then the section desired, or alternatively print the manual on the printer. Chapter 3 describes the theory behind the calculations. The program window is divided into 3 parts. One window that handles input data, one that displays graphics, and finally one that recognizes current printout. The program has 2 modes, Design and Control. In Design mode, required reinforcement is calculated with respect to the capacity in the ultimate limit state, while in Control, a given reinforcement is checked in the ultimate limit state, and stresses as well as crack widths are calculated in serviceability limit state. We start in the Design mode. In this program, the load case is superior. This means that the calculation can be performed for load cases with various inputs such as different cross-sections, buckling lengths, and materials. The data entered will therefore only apply to the active load case, which appears in the program window's upper right corner, which is important to know. Often, however, one wants the same cross-section, buckling lengths, and material properties to apply to all load cases. If so, one activates the option Linking Load Cases, as we will see later. We begin with the option Input and select Title. Here the data is specified that will be displayed in the header of each printed page. With the option Convert Code Version, one can easily switch between the various annexes included in the program. Besides the Swedish, also the British, Finnish, Norwegian, and Danish are available, in addition to the standard values available in the code. Under the tab Section Information, with the option Section Database, the current section type and measurements are specified. We choose non-standard concrete, and possible cross-section types are rectangular solid, variable rectangular section, T-section, variable T-section, solid circular section, single symmetrical I-section, F-section, and F4 section. We choose in this case solid circular section with diameter 500 millimeters. Under the tab Load Case, the following can be defined. Possible moments about the Z and Y-axis, compressive axial force, the initial bow imperfection value, and if the load case is an ultimate limit case or a serviceability limit case. For ULS load cases, can also be specified if the load case is of type accidental, and for SLS load cases if the load is short or long-term. We specify 2 ULS cases, Ultimate 1 and Ultimate 2. Ultimate 1 contains a moment My of 50 kN and an axial force of minus 3,800 kN. As it is always compression force in this program, it is defined negative. The initial bow imperfection value is set to 490, meaning the initial bow imperfection is L divided with X, where L is the column wall height. The limit state is finally selected to ULS. For Ultimate 2, we define My 75 kN and axial force minus 3,400 kN. Otherwise the same. We also want to specify a SLS load case, but as such load cases not can be designed, only controlled, we await with this to program mode